Hello. Hey, if so, who all have joined? Aditya has joined, right? And Abu Baker has joined. So, I mean, you can go on mute, and yeah, we'll start our class in like 4 to 5 minutes. We're waiting for some more people to join. So, yeah, I'll introduce myself once we'll start with the class.
Hi, Aditya.
Hey, who is there?
I'm Abu Bakr.
Hello, sorry.
Abu Bakr. So, do we have a recorded session of this?
Sorry?
Do we have a recorded session of this?
Yes, so we are recording this session.
Okay.
Yeah, so you can actually go and check the same session again later on.
Yeah, cool.
Yeah, I'll introduce myself once like everyone will join, and then we can start with the class. There is one more thing. So if you have any questions or confusions, or if you want to discuss something out, feel free to come up with your thoughts and feel free to speak.
Sure.
Yeah, great. Just to confirm, can you see my screen? Hello?
Not yet.
Oh, okay, let me just share it out. Yeah, just let me know if you can see my screen.
Yep.
Yeah, okay, cool, great. Yeah, I will wait for like 2, 3 more minutes and then we'll start. Okay, cool. So it's already 1:10. Meanwhile, I'll introduce myself and then we can start. And yeah, so feel free to jump in if you have any doubts or if you have any questions or if you have any suggestions, because it's more like a design class and we can have different views, but it will be good if we can discuss out all those views and come up with a better solution. So I'll try to give my best. If you have any suggestion in mind, please feel free to jump in. Okay. So by the way, I'm Prakhar Agrawal and currently I'm working at Google Bangalore. Okay. So let's start with the session, and you can go on unmute and just give your suggestions whenever you want. Okay. So today the class is about the shortening URL. So okay, there is some chat message. Hey, we have started. Guys, am I audible to you, right? I'm audible to you, all right? Can anyone just go on mute and tell me if I am audible or not?
Yes, you're audible, Prakran.
Yeah, cool, 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 cool. So let's start with the, and please, actually, uh, so you might be on mute. All other can. Cool. So, and just if you have any question, instead of actually posting it on chat, you can directly ask the question, just go on mute and just ask a question. Okay. So what basically is shortening URL? So let's see what is shortening URL first. Okay. And what it is. So can anyone tell me what exactly is shortening URL? Yeah, so basically shortening URL is a URL which actually converts a big URL. Let's say you have created a doc page, right? It might be of a length of 100 size. Now the URL might be of size 100 and you want to share that URL with someone. It's very difficult to share that URL because it takes a lot of size, plus it's difficult to display. It doesn't give you a good it doesn't give you a good look at all. So what do we do is in that case, we shorten that URL. And there are few online websites you might have used, like tiny URL, and I mean, like there are some google.gl URLs which you can use. So there are multiple URLs like that which we use to shorten the URL. So what is URL? So it provides basically an alias for your big URL. And what does it do? It also provides you the redirection. Correct. So whenever you click on that short URL, it will redirect you to the longer URL. Correct. And why do we need it? So can anyone tell me, like, why do we need it? Okay, so there are two major reasons. There can be many more. So it saves your space. So let's say if you want to display this, or you want to share it on Twitter with someone, or let's say if you want to send it to someone, then it saves a lot of space. What is the second reason? Second reason is that if someone less unlikely to mistype. So if let's say someone wants you share the URL with someone, and it's let's say it just contains 6 characters, so person can easily go and type it, right? If it's a long URL, it's more likely that person may put one or two characters here and there, and the URL might be wrong. Okay, so I'm just writing all the use cases first, and then we'll talk about each of those cases later on once we'll go ahead. Okay, so these are the major reasons why we need a shortening URL. Now, let's talk about features and requirement. So I hope everyone understood the question, right? If you have any doubt, then please tell me. Okay. So let's say a question is given to you that you need to design a shortening URL system for the URLs generated in your company. So how do you come up with the solution? So first we need to gather the requirement. So in any of the design question, the first basic most thing is that you should know what are the features and requirement we need to complete this particular design. Okay, so let's start with let's start discussing one by one features we need for this particular design. So can anyone tell me the major features we will need in this particular design? It will be good if you'll participate, because then it will be easy to understand for you guys as well. So don't hesitate to come up with your solutions or to talk. I mean, it's okay if you are wrong, or actually there is nothing wrong and right in design. It's just a different thought. So you can come up with your solutions as well.
So
Yeah, tell me.
One of the features will be taking the long URL and then returning the.
Correct. So that's a major requirement of our system. So we should be able to consume the long URL and should be able to return the shorter URL, correct? What else?
By clicking on the shorter URL, one
Correct.
should be able to redirect to.
We should be able to redirect to the longer URL and display the page, correct? What can be the additional? So these are the major features we need in our system. What are the additional features we may need? So user should be able to optionally pick their URL, right? Optionally pick URL. So we should give user an option to pick their own URL. And if it will be available with that the shortened URL will be available with us, then we'll provide it to user, otherwise we can deny. So optionally pick URL, that can be another feature. What else can be other features? Anyone? Okay. So the fourth major feature can be that you should be able to expire that URL after some time. So let's say user logged into our system and user want to delete that URL after a time because there might be some privacy reasons or security reasons. So we should give them option to delete their URL, correct?
Yeah.
This is not very major reason. This is very, very optional, because what they can do is they can just remove that URL, that page itself. So it will give it won't display anything even if we redirect. But see, it might be a bad user experience. So at the first place, we may want to give the user option to delete the shortened URL. Now there can be, so these are the functional requirement for our system. What can be the non-functional requirement? So okay, let me discuss this first. So what are the functional and non-functional requirements? So the functional requirement are the requirements which user asked from us to provide to them, correct? Let's say if your manager talk to you and ask you that, you need to design a system which will give me a product manager basically, right? Design a system which will shorten my URL. So you will gather all the functional requirement from them, because that should be the function of your design or your system. What are the non-functional requirements? Non-functional requirements are the requirements which usually developer or your PMs take care of it. Okay, so let's say your system should be available, correct? So system should be available, correct? So can I say highly available? Because we don't want our system to go down, because someone is trusting us and creating the URLs out of us. And if there is any redirectional URL, then if we'll give an error, it won't be a good user experience. Okay. And what should be the other non-functional requirement? The redirection should happen in the real time, correct? Okay. If you have any other, if you can think of any other non-functional requirement, then please feel free to jump in. Okay. Any confusion so far? Any questions so far? Okay, cool. So we have gathered, guys, feel free to talk, because this is like a design problem and we need to come up with a solution altogether.
So, I have one question about non-functional requirement.
Sure.
So generally, like people when share the URL like google.com/doc or something like that. So the person who is going to open it, they know, okay, it's from google.com, so we can open it safely. So if we just shorten the URL and it doesn't contain something like related to Google, the next person whom you are sending, he might not open, because it can be a mass marketing, correct?
Correct.
So that can be added in non-functional requirement, correct?
So what exactly is your point? Can you just
so whenever you share some link to someone, that person only generally people open when it is something like related to them, like if they can relate to that URL, like google.com/doc. So it's like Google some document, correct? If you're sharing some document with someone.
Correct.
Yeah, but if it contains some xyz.co.
Okay. Yeah. So you are saying that it makes sense to have we should give the user the facility to actually come up with their own URL, right?
Yeah, like something readable, like which they can relate.
Correct. So optionally pick URL. So we are giving this function. So that's a functional requirement of our system. That's not a non-functional requirement, because the developer should not decide this. They should come up from the PM or the users itself that I want this URL. So I should be able to create my own URL. This will be the requirement from the user side. You're making an exactly correct point. So can I write here readable URL? It will make more sense.
Yeah.
Correct? Yeah,
Yes.
nice point. Very correct. Yeah, I totally agree with you. So,
And another point can be like the two URLs should not collide actually. If someone is short.
yes, but that our system should be able to handle it on itself, right? That's why we are designing the system. We can add it, but that's a major function, so it should not collide. Let's write it down here. Correct. But that will be again that will be a non-functional requirement, which they don't, because the user doesn't care, right? But we should care it on our side that it should not collide. So can I write it here? Correct. Shouldn't collide. Makes sense. Anything else?
Yeah, that's all from my end.
Okay. Let's jump on to the next part. Cool. So now, once we are done with the features and requirements, we need to make some estimations and we need to put some constraints on our system, right? Because see, in a design question, if you will come up with something, if let's say you are in an interview, so your interviewer you should ask your interview that what is the scale, what should be the scale of the system? For how many users I'm designing this system? Because without that, it will be difficult for you to come up with the right design. So let's discuss out the constraints and estimations. So here we'll make some assumptions initially, and then we will come up with the correct estimations, okay? So let's say we want to design a very, a system which supports a lots of users, which supports a lot of redirections, and we know that our system will be traffic heavy. So can we say that whenever we generate a URL, the read will be more than a write. So what I mean by write is that to create a shortened URL from a big URL and to redirect from that short URL to big URL. What do you think? What will be your major use case here? I think the read will be more than your write. That's why we are creating a shortened URL, correct? Because we want to share that shortened URL with multiple users. So can we say our system will be read heavy? And there will be, as I mentioned, that there will be a lot of redirections. Okay, let's assume a ratio will be 100:1. Okay, so this will be read and this will be write. Any questions so far? Okay, so we know that our system will be read heavy, and the ratio, we are assuming a ratio of read to write is 100:1. Now we need to estimate some traffic. So let's say traffic estimation. You guys know, right, what is traffic estimation? Okay, let me explain it to you. So yeah, go ahead. Yeah, anyone was saying, like, any one of you were mentioning something? Cool, I'll tell you what exactly is traffic estimation. So traffic is, in simple terms, is number of users hitting your system within a second. So that's a traffic for your system. So we need to estimate the traffic of our system, correct? So let's start with the month. Like, let's say in 1 month, how many URLs will come? Just a minute. So let's say in 1 month, we are generating 500 million URLs. Is that fine? 500 million URLs in 1 month. Okay. So we are designing a system of scale of Google, or let's say tiny URL, or bit.li. So these are all the systems which actually provide currently your shortening URL. The feature of shortening URL. So, so what will be your? Can anyone tell me what will be the redirectional hits in a month? So we have assumed that these many will be writes, correct? These many URLs will be created in a month. So according to our ratio, can anyone tell me? So we took the ratio of 100:1, right? So how many reads will be there? Can I say 500 million into 100, which will be equal to what? 50 billion, which is like a huge number in itself, correct? So redirectional hits in a month will be like 50 billion. Now we need to calculate the QPS. Can anyone tell me what is QPS? Okay, so QPS is query per second. So how many requests will get in 1 second? Okay, so we will get for read, let's say, for write, let's say we have 500 million URLs. Okay, sorry, 500 million URLs divided by 30 days in a month into 24 hours in a day into 3600 seconds in an hour. Okay, that will be approximately equal to 200 URLs. Now you can make some assumptions, like this will be like you can consider this as 30 into 30 into 3000. So this will be like 3 into 3 into 3. So you can consider it as 200 and something like that, and then 500 million divided by this will give you approximately 200 URLs. Okay, this calculation you can do during the interview itself. Okay, now let's talk about the read URLs. So if my create URLs are 200, then what will be my read URL in a second? 200 into, come on, 100, right? Because our read is to write ratio is 1:100. Sorry, 100:1. So it will become 20,000 URLs. Correct? Any confusion so far? Okay.
So you had 500 million URL first for write, correct?
So what I did is, let me repeat it. So I said that we will have 500 million URLs. We'll get 500 million write URLs, basically to create shortening URL in a month. Okay. So what will be the read URLs or redirectional URLs? That will be not URL, sorry, redirectional queries, redirectional hits. So that will, our ratio was 100:1. So for one write, we'll have 100 reads. So for 500, we can say that we'll have 100, for each of them, we'll have 100 reads. So total reads will be 50 billion. Okay. So 50 billion was in a month, correct? So this was in a month. Now I need to, so whenever we design a system, we design it to actually should be able to take load within a second. So we need to make those calculations, right?
Okay.
I said that write is 500 million in a month. So what will be the queries per second? So how many queries I can get in 1 second? So write queries will be 200 in a second, assuming this is the data we have got, okay, with our assumptions.
Okay.
And read will be what? 200 into 100, that is
20,000 URLs.
20,000 URLs. Any confusion? Any other question?
No.
Okay, let me see. There is some message. Actually, we are already recording this session, so you don't need to worry about it. You can, Aditya will share the link with you later on. Yeah. So you don't need to worry about recording it by yourself. We are already recording the session here. Okay. So here it says recording to the cloud, and then later on the link will be shared with you. Okay. Now, let's say we need, so once we are done with this, we need to make some storage estimations as well, because we need to store all this data into our database, correct? So can anyone help me with the storage estimations? So let's do one by one. So let's go storage estimations. Okay. Okay. So let's say we want to store all this data for like 5 years. So how many URLs will be generated? Can we calculate that? So URLs in 5 years. And we are assuming that, I mean, we will have the same traffic for next 5 years, which won't be true. So we may need to add some systems later on, but let's say that is static for now. So in a month, how many URLs requests you are getting? 500 million URLs. So 500 million into 5 into 12, correct? So which is equal to 30 billion URLs, correct? 12 5 60, 6 5 30, so it will be 30 billion URLs in 5 years. So this will be what number of URLs we need to create in our system, correct? So these will be all, number of URLs written in our system within 5 years, correct? Okay. Any questions so far? Okay, now tell me something. We need to make some more assumptions here, right? What will be the size of one URL given to me? So can anyone tell me what is the size of one character? Hello? So one character is equivalent to 1 byte, correct? Now, can we assume that, so we will need some space for creating the hash, we'll need some space for creating the URL, shortened URL, we'll need some space for storing the big URL as well, because there we need to redirect finally. We may need to store some other details like timestamp at which it was created, timestamp at which it will expire. Then we may need to add some user infos, which we took from the user during the creation of the URL. So can we assume that the size of each of the value, size of each of the row to manage this data will be 500 bytes, 500 characters. So I'm assuming 500 characters because let's say username will be in string. The URL given, so shortening URL which will generate is again a string, and the URL which we will generate, the URL which we need to convert is also a string. And then there is some other infos which will be like around 50 bytes. And let's say the big URL is of 200 bytes, the smaller URL is of 50 bytes, other info is of 30 bytes. So let's assume like approximately 500 bytes we need for each of the entry. So can we say that for 30 billion, we need 500 bytes, correct? Which is, so these are bytes, memory. This is the memory we need, okay? So 530 billion into 500 bytes, let's convert into TBs. So bytes to KBs will be 1024, and to KBs to MBs will be 1024 into 1024 gigs and 102 Ts. So it will be, so we can assume that this is like 10 to the power 12, which is approximately equal to 15 TB. So 5 into 3, 15, and then all these zeros will go, because 3 zeros will come from here and 9 zeros will come from this billion. So what will be this? It will be around, I mean, yeah, 3 zeros from here, but there are 15 and then 9 zeros from billion. So it will be around 15 TB. Okay. This is the approximations. These are not the exact values, but we need to make some approximations before designing our system. So these are the 15 TB. So we need to store this much of data, correct? Within next 5 years. So all these assumptions are now for the next 5 years. Okay. Okay. Any other questions or confusion so far? Yeah, feel free to jump in if you have any question, any confusion. If you want me to repeat any part, because these are very important parts, I'll just ask you to guys to have a quick look. If you have any question, then please ask. So this is the redirection in hits in a month, QPS, and how I calculated each of this. Okay.
500 bytes means you have taken a URL as a 500 characters, correct?
Sorry?
The 500 byte assumption we have
Yes.
taken.
So it is not just the number of characters in my URL. So there can be many more info. So why it took 500 bytes? Let me write it here. 500 bytes. So there can be multiple reasons. So let's say we are storing the user information. The user info is basically the user who has created this URL. So name, let's assume like 50 bytes.
Okay.
That details we may want to store for the user. Then let's say our shortened URL is of 20 bytes. These are all approximations, okay?
Okay.
And then let's say this is short URL. Long URL is of, let's say, 350 bytes. Okay, so this gives me around 420, and then maybe timestamp and other may consume some other details. Here we may need to store some other details. We need to store some expiration time. So overall, I approximated it to 500 bytes. You don't need to give the correct number ever in the interview because this is a design question, but you should be able to come up with some number, which is good enough for the estimation. Okay.
Okay.
Yeah.
Okay.
And any other confusions or questions? Yeah, I'll give another, like I'll wait for 1 minute because I know this is heavy to digest, but I want you guys to understand. And if you have any confusion, then please feel free to ask. Give like 1 more minute. I'll wait here for a minute. Okay, so what other estimations are required here? Okay, so let's say if we want to design our system in such a way that we want to design a cache for our system, correct? So can you tell me what is the cache? What do you mean by cache? So these data, this all data will be stored in our DB, right? So it will take, I mean, the time to actually access that data will be a bit longer compared to the data which can be accessed from cache. So I'm just asking, like, if any one of you can tell me what exactly is cache?
It's a temporary storage.
It's
like a temporary storage. See, for example, you are getting some reading some data from the database. Okay, first time. So we can't like, for example, that your requirement that we are not going to change the data frequently. So instead of going to database and getting the data each and every time, so we can get the data from the cache in middle. So
correct, very correct. And in our case, if you'll see, Once we have generated the redirection URL for a bigger URL, we will never ever going to change it. Correct?
Yeah.
Correct. So in our case, it totally makes sense to cache it. But is it possible to actually cache 15 TB of data? Don't you think it will be very, very costly for a company to actually create a cache of 15 TB? And then what is the use of database? So we can't cache everything. So your answer is 95% correct, but you're missing that 5%. Can you tell me why can't you create a cache of like 15 TBs itself? And what is the major benefit of cache?
It is
Compare it with your hard disk.
Yeah.
it is highly accessible. Cache is highly accessible, and
Correct. Even see, highly accessible is not a right word. So even your date, we'll have to divide and actually design our database in such a way that it should be highly accessible as well. The right term to use here is that the latency. So latency to reply for a particular query will be very, very low if we have an entry in cache. Okay, let me try to put some more, let me try to explain this particular term more. So if you'll consider this, right? So there we have different kind of storage. Okay, so the storage can be your disk, then you can have RAM, then you can have cache. In cache also we have categories like L1, L2, L3, and then we have registers. Okay. So time to access data from registers is very, very less. So time decreases from here to here. If I get a network call and if I can return the data from my register as compared to disk, the turnaround time for that particular query will be very, very less if you will return the data from the registers. So we have registers, cache, RAM, and disk. But the cost, so time decreases, but the cost, time, can I say time, turnaround time decreases. Correct. But the cost of register is very, very high compared to your disk, or the cost of cache is very high compared to your disk. So your cost also increases. Cost increases. So I can write time increase. So it's better to write it like this instead of this. Time in turnaround time increases and cost decreases. So basically what do we do is, if we want to store everything, if you want to store the, okay, now the second question, right? Let's not jump onto the solution directly. So we know that now we can create a cache of 15 TB, correct? Because the cost to actually purchase cache compared to disk for 20 TB, let's say, will be very, very high. So we can't actually, none of the company can actually support this much of cache. I mean, I'm just assuming, like, if you can, I'm assuming this data, definitely we have cache of 15 TBs in like many companies, but the systems are large. There the disk will be of like petabytes or maybe like more than that. So yeah, so it depends, right? So here, in our case, if we can store the data of 15 TB in our disk, we can't create a cache of 15 TB. Because, okay, so now how to decide that what data to keep in cache and what data to keep in your disk, okay? So we have, in general, we have a 80-20 rule. So what is that 80-20 rule? Have you heard of this rule? This is a very famous rule which is used at multiple places. for caching. So as I mentioned that we don't want to store everything in our cache, we need to come up with some strategy. So basically 80-20 rules tells you that 80% of the data which will hit on the, just a minute, there are some messages. Please mute yourself. Cache reduces response time. Oh, this is awesome. Nagappan, actually you can speak up as well. Cache is for most frequently used data. Correct in a way, wrong in a way. Yes, fast read, definitely agree. So it depends what is your caching strategy. So we'll discuss the caching strategy in the next class, not in this one. But yes, you can say that cache is for most frequently data. It depends on how you are designing your cache. So we can't say that your cache will be for the most frequently used data. But yes, generally that's the strategy we use to design our cache. But yeah, I'll discuss about this later in like some other class. Okay. So yeah, what is 80-20 rule? So it says that 80% of the data will be accessed. 80% of data will be accessed 20% time, and 20% of your data will be used 80%. So the request you will get 80% will be for this 20% data of your accessed data. Correct. So tell me something, which data you want to store in your cache, because cache is very costly. So we want to store this 20% of the data in which we know the like we can return the response very quickly because we have already stored this data, and this in cache, and then there will be a lot of it for this particular data. But now we need to know that what is that 20% data, which is very difficult to predict at the first place when we are designing our system. So we will see how can we cache it later on. But yeah, but that is we will need to have some caching strategy in our system so that we can return this 20% data very quickly, because that will be accessed 80% of the time. Any questions or confusion so far? Okay, I'll give another like 1 minute to understand what is cache. If you have any confusion, if you want to ask anything, then please feel free to ask. I hope everyone understood this 80-20 rule. Yeah, so guys, we didn't do the estimation of the cache we need to create. So cache will be of what? Can anyone tell me what will be the size of the cache? Like, I'll wait for your answer this time. So size of cache.
20% of that?
20% of what?
15 TB.
20% of 15 TB. Which will be what? Equal to
Caches
3 TB?
3 TB around.
Correct? Great. Yeah, that is correct. And can anyone tell me what will be the number of requests hitting on the cache? So the number of requests we were getting, QPS.
500.
What was the QPS? So the QPS was around, we can say read plus. So see, the data which will be read from our cache will be only read data, right? There will be no write data in the cache, correct?
Yeah.
So it will be 20% of this 20,000 URL,
Yes.
correct? In a second.
80%, right? Like.
Oh, yeah, correct. Sorry. Yeah, correct. So 80% of that 20,000. That's correct. I'm sorry. Yeah. Yeah. So yes, you are exactly correct. So the hits on the cache will be
Around 16,000.
yes. Makes sense. So 20K, 80%, it should be around 16K. Correct. This is like this is per second. Okay. So now you see what is the use of your cache. because it totally makes sense to make the cache for this 20% of the data. Sorry, yeah, 20% of the data, 80% of the head. Yes. So, yes. Yeah, that 20% of the data will be accessed 80% time. So that it totally makes sense to make a cache of your 20% data, which will be accessed 80% of the time.
So currently it's very difficult to predict at what that 80% of the data will be, right?
Yes. So initially we won't be able, yes, initially we won't be able to decide that what is that 80% data. I totally agree with you. Totally agree with you, because we don't know. That we'll get to know with time, right? So we'll have to have some strategy. So we'll discuss the caching strategy separately. Okay. Once we'll come up with our design and how can we come up with the right caching strategy and what data to store in the cache. Okay. Sounds good?
Okay. So
Yeah.
what, just out of curiosity, it can be 60-40% of
It can be 60-40% as well. We don't know. I mean,
you don't know, right?
we actually don't know, but we are making that assumption, right? It can be 60%, 40% as well. It can be 90-10 as well. So see, when we actually come up with our system, we need to make some estimations because we don't know the size of the traffic as well. We said 500 million, but it might not be true. We might get 1,000 millions a day, 1,000 millions in a month, or maybe more than that, or we may not even get 50 million in a month. So see, initially we are making some assumptions. Based on that, we will design our system, and based on the graph or the base. So these are the static data we are assuming before even designing the system, because we need to design a scalable system. So even if, let's say, if we are supporting 500 million right now, we know that suddenly the traffic won't go to 1,000 million, right? Or suddenly the traffic won't drop to 1 million or 10 million,
Yes.
correct? So initially we are assuming few things. Yes, later on, definitely you may need to evolve your systems with the data or with the graphs you see, with the traffic you see in your system, correct? So I totally agree with you. So we can actually take this as a 90-10 rule as well. But if you're saying 60-40, so again, it's very difficult to create a cache to actually buy. It's not difficult. Basically, it's very costly to create a cache of 40 gigs. 40 TBs, 40% of your disk, so which will be around what, 6 TB, correct? Sorry, 8 TB in your case. So it's very difficult. So that's why we have make this assumption, because it makes sense to make this assumption. Later on, if we'll see that we are getting a lot of it, then yes, definitely we may need to change our cache size. And if it is profitable for us, so there can be multiple reasons for it, right? You may start your system without even introducing the cache at the first place. And once you know that you need cache now, then only you need to introduce your cache. But before that, you need to collect the data and then make the assumption. I mean, initially we may not create a cache for our system because we know the traffic won't be so high. And once the traffic will be like start going on a, like we can see the spike in the traffic, then we can introduce our cache in the system later on. Okay, make sense?
Yes. Cool.
Yeah, tell me. I mean, if you're still not satisfied with my question, then please,
No.
sorry, with my answer, then feel free to actually suggest. Because see, this is a design class, right? I mean, I may be wrong here, because it depends on how you think. There are like thousands of design for this problem, and this is my personal design. So I may be wrong, but yes, like most of the time this works fine. So yeah. But yeah, if you have any other suggestion, then please feel free to go ahead and come up with it. Yeah, you were saying something?
No, I got your point.
Okay, cool. Anyone else? Any other question? Okay, so now we are good with the estimation part. It depends how we are designing our system. So we make these assumptions to start with a correct design system, with the correct design layers we want to design for our system. So we have done those, and now let's jump onto the design part. Okay. Yeah. So me write here design. Okay, can anyone give, okay, let me try to draw a diagram on high level how our systems will look like. So basically we will have multiple clients, basically your web servers, which will hit your application layer in which you have written your services, the business logic. So it may hit, so let's say we have, sorry, we have services running on 3 different servers right now. All these clients will hit those services. Now there will be a layer. I'll tell you what exactly this is later on, but for now, let's assume that this is there. Okay, it's called as load balancer. I'll talk about this later. And then these services will have the logic to actually come up with the right URLs. And then what else we need here is the DB. So here we'll have another load balancer. Store this data in the DBs. There can be multiple DBs. Then we may have clustering and sharding strategies that we'll discuss later again. So let's say this is my DB layer. So if you have any questions so far, then please. Data, or can I say data storage layer?
So cache will be part of your load balancer, or it comes in DB layer?
Sorry?
The cache will be, load balancer will be just handling the request, correct? Nothing else.
Correct.
It's not giving data or anything.
Basically, these are your services, right?
Yeah.
So load balancer will just balance the load in your services. And those services should be able to access your cache. So here we'll have somewhere cache, which each of the service will talk to. And if they will get the data from here, they'll return that data. Otherwise, they will go and hit this particular load balancer to read the data from your DB. Okay, I don't know if I've designed it in a well manner or not, because it becomes very difficult with these arrows. Let me try to correct it or write it in a better way maybe, because you may use this for later. So this is so service will go, and so this will be your first step to check in cache, and this will be your second step for each of the servers which are introduced on the service layer. So they will go on check on the cache, and if it is hit, they will return the data. If it's a miss, then they will hit the DB. This might be your second step. This might be your second step, and then finally, once you get the data from here, then you will write it. And it again depends whether it's a read request or write request. So if it's a read request, then it will hit the cache. If it's a write request, then we won't hit the cache. We will hit the DB directly. Okay. Any other question? Okay, hit on cache again. Yeah. So what is hit on cache? Let me explain it again. Let me write it down for you guys. Someone has confusion in hit on cache. Okay. So basically what happens is that you get, let's assume 3 simple circles. Okay. One, this is my service, which will get the request. Forget what is happening before this. Here I have my cache. And here I have my DB. Okay. This is my DB. So a request comes in. So this is my request. This is the first step. Okay, can I write it as first? Here a request comes. Now this request will be a read request, because we are, let's say it's a read request. Okay. So we need to read the data So we need to actually redirect it to the URL. So we need to provide the larger URL for the shortened URL. So what we do is we go to cache. Now we will have a unique key for each of the URL, the shortened URL we have generated. It will go and check in the cache that do I have the data for this particular request or not. So this is my second. Now it will return the response. So the response can be failure, basically not known, unknown, or the response can be that this is the big URL. So this will be the response from the cache. Now, based on the response received on the service, so this, if we get the data, if we get data from cache, we call it as cache hit. If we don't get the data, no data in cache, then we call it as, can anyone tell me what is the term for that? Okay, it's a cache miss. So if it's a hit, then we will return back the response. Correct? Because we got the response from the cache. If it's a miss, then what we will do is we will go and talk to DB, because we know for sure that the data is present in our DB. So this will become my fourth step. Okay. Now, so this can be my fourth, because this is my response if I get the hit. If it's a miss, then we'll go to DB, we'll get the data from DB for sure. Once we'll get the response from the DB, the service will return the response to the caller. Correct? So now in this case, it will be always hit on the DB, because we know that we have stored this data for sure. It's quite possible that if someone tries to enter some invalid URL, then it will be again miss on DB, and then accordingly will return the response to the user. Okay. Yeah. Is that clear, or any other confusion? Any questions here on cache miss, cache hit? Give like a half a minute for this to like have a look again. And don't worry, I'll keep like extra 10 minutes at the end of the class, so that if you have any questions, you can come up with the question at that time. If you have questions, then yes, you can feel free to ask right now. Yeah, and thanks for asking this question, Nagappan. Thanks. I don't know how many people know this, so it's very helpful if you don't know this. How does it work? Cool. Let's jump on to the next part. So we were on design, right? We actually came here in between. So let me write the topic for this. This was my caching. And then we have caching strategy as well, like what is basically your eviction policy, what is your caching policy, and we will discuss all those in some other class. This is the class mainly meant for your generating a tiny URL. So we will have a different separate class on caching. Cool. So let's get back to design. So yeah, basically we need a two major layer in our case. One will be your application layer. And the other one will be your storage, data storage layer. Okay. So now let's talk about the application layer first, and then we'll talk about the data storage layer. So on application layer, what all you need, what all services you will need. So I hope everyone understand like what is the service, right? Or API. So let's simple. What is what all APIs you need on your application there to support this system? Yeah, anyone? Okay, so the first one will be create URL API. This will be basically your write. Correct. Second one will be your redirect URL API, which will be your read. And then the third one can be delete URL. This can be optional. And this will be again write. These are the two APIs which are used for mutating, and this is uh, used for reading. The write, comma, can I say optional? I mean, we may not initially, we can skip this option, and later on, once we are in a good stage, then we can introduce this URL later. So let's talk about each of the URL one by one, and then we'll jump onto the DB side. Okay. We need to talk about the algo as well in this. Correct. So, I mean, here, to make it simple, let's say we have the REST URLs, REST APIs, REST APIs. Create URL. Sorry. Yeah, the first one is create URL. Okay. Now, based on the discussion we had so far, can anyone tell me what all fields you will need in create URL? Guys, I want to hear from you. People, like, I want to hear from you what all fields will need in create URL. And this is like a very simple.
We get
Yeah. Tell me.
actual URL string in
So, okay. So let's
Domain,
one by one. So what do you need here is,
domain,
just a minute, sorry. Can I say string? Let's try to keep it as simple as possible. String for what?
string
For redirect. So the large URL, the
for the actual URL. Yeah.
actual URL. Let's name it as actual URL. Cool. Actual URL. So this will be your request, right? Let me write here request.
And some options.
This will be your request. Yes. Okay. So this is your actual URL. What else you need? Yeah.
Options. We had written one feature like optionally pick URL.
Yeah. So pick URL, right? So string.
So this is the user suggested you pick URL.
Sorry.
This is the user suggested pick URL. But what he wants.
Yes. Yes. This is the user's pick URL. The user says this is in the request, right? And this is like required field. So these can be optional fields. These are the required fields. Okay. What else?
Expiry of that. By default, we can have some value, or else we can take it from the user.
Sorry.
Expiry.
Sorry. Breaking.
Is it audible now? Hello.
So what? Yeah, I can hear you.
Yeah. So expiry.
Time.
Expiry of the particular time to expire, basically.
So timestamp. Can I say timestamp?
Yeah.
Expiry time. And this will be also optional.
Optional. Also, it can have a default value.
It can have a default value of 5 years.
5 years.
Correct.
So it does not become optional, right? Optional from the user side. Yeah.
See,
Yeah.
optional from the user side,
Yes, yes.
but for us it will be default 5 years. I'll write optional. I mean, we can autofill this field with 5 years, and then if you user want to change it, you can change it to any other. Okay. So it's not an optional field, so we can remove it here. Default 5 years. We'll give the user to pick time. Basically, we can display some calendar entry or something here. That's a client-side thing. That's a UI, right? So we don't care about it. Here we are designing the system on the service layer. So we will definitely get this value in our URL. So client will populate default 5 years. Otherwise, we'll have some time. What else you need? Okay. Let's say if you want to support a delete URL functionality later on. Okay. Then, okay, let's say if I create a URL, right, today, shortened URL, and tomorrow someone comes in and they just call a delete URL with my URL, then in that case, should I delete it or not? Should my system delete it or not? Hello?
Yeah, it should delete it.
It should delete it. So let's say I created a URL. Tomorrow you came and deleted it because you want to use it for your own purpose. Then should I delete it from my system? No, right? Because someone else should not be able to actually delete my URL. They should not be able to mutate on it. They should be able to access it, but they should not have the mutability functionality. Correct? Do you guys agree or not?
Yes.
No, because let's say if I want to create so let's say for a simple example, right? So let's say you have a YouTube page for you have started a new company. You have created a YouTube page for it. You have generated your shortened URL for that to share it with your clients. Okay. Now there is some other company which came up with the same plan. Now what they did is they wanted to pick your same URL, right? And you have created a shortened URL on my system. Okay. Now they came and saw that, oh, you have the shortened URL, and then I want to, and they've already shared this with like multiple clients. And if I just can take this URL and redirect it to my system, then I'll get much more traffic, and then I'll automatically start getting traffic for the other company. Correct? You getting my point? So if they'll be able to generate the same, they'll be able to have a same shortened URL. So if your client will click, it will redirect to the different URL. So in that case, it doesn't make sense at all for my system to actually give the delete permission or mutability permission to that person, because that person has not created this URL in the first place. The person who should be able to delete this URL should be the person who has created this URL. Correct? Is that make sense to you guys or not?
Yes.
Correct. So what should we have is you need to take some user permissions, but you need to hash it because you can't directly read it. So let's say we take some user identifications. What kind of user identification? It can be that we can create a user identification on our side as well, or we can actually ask them to enter the username and then create a hash out of that username by appending some more values into it. So this is one of the options, but this is not a good option because two people can have same username as well. So you may need to append something, or you may need to have some unique ID, let's say Aadhaar number or something. I mean, see, Aadhaar number is not a right place to mention it, but I just want to bring it up because it should be unique. It should be able to uniquely identify a particular user. So let's say it can be my Gmail ID, correct? That will be unique for that person, and that person has to give the allow permission on the Gmail ID to access my particular URL. So they need to log in onto my platform, and then only they can come up. So if they don't have the password of Gmail, they won't be able to any other person won't be able to log in with my username on Gmail, and then I can collect this data from Gmail and then keep it on my site, correct? So let's say username, or we can have email address or any other thing. And this will be again a string. And this is again optional. So if user has not filled it, then we won't give the delete functionality to that particular user. Yeah. Any confusion here? Okay, cool. So this is my create URL request. What will be my create URL response? Yes. So response will contain my actual URL, which will be again a string and a shortened URL. Correct? And if you want, we can display the expiration time as well to the user, but it is not required in this case. I mean, it is optional. Anything else if I'm missing anything? Like, if you see I'm missing anything, then please tell me. We just want the actual URL and the shortened URL, right?
So I just have one question here.
Sure, tell me.
So with this create URL API, the whole plan is to generate a shortening URL particular to a user, right?
Not a particular to user, particular to your actual URL. This particular to the actual. There can be, so for a user, there can be multiple actual URLs, correct?
Right.
So one URL, one short URL for a user for that particular actual.
So let's say you try to create a shortened URL for some URL XYZ, and I try to create the same thing with my let's say mail ID. Would that both URLs be same, or would it be different?
Sorry, I didn't get you. Can you please come up with the question again?
So let's say myself and yourself, we want a shortened URL for the same actual URL,
Okay.
right?
Okay.
So what would it be? Would it be the same URL that both of us would receive, or would it be different?
Okay. Yeah, your question is totally correct here. So what do you think? What should it be? I mean, it depends on, so like there can be two answers to your question. So see, it depends what are the primary keys in our table. So it doesn't matter if two people are trying to create two actual URL, two shorten URL for a same actual URL. Okay, because the hash key will generate and the okay. So I'll discuss the algorithm later, but yes, yes, it can totally happen. Or what you can do is, if you can always, if your actual URL is not a primary key in your table, as long as it is not a primary key, it is fine. As soon as it becomes your primary key, then it's a problem. So you can generate two different URLs for the actual URL, because later on you may want to support the delete functionality, and that user should only be able to delete that particular URL. So it depends on the totally on the system design you want to keep in your mind. But yes, you should be able to support this functionality at the first place. Correct. I totally agree with you. Correct. It should not be a same shorten URL, right?
Right. I mean,
correct. So we can totally
because the delete wouldn't make sense. So that's where I was going.
Yes, correct. So again, if you're planning to support that particular use case later on, then you should keep this in mind while creating your system. And that's why we make some assumptions earlier. Yes. And it proves my point, right? That the system, you should make right assumptions at the first place to come up with the right design. Otherwise, it will be very difficult for later on to actually, once you make actual URL as your primary key of your database, it will be a problem, because you need to migrate your whole data to new DB. You'll have to have a new key, new primary key, and then you need to come up with a solution. So yes, it makes sense to have two different shorten URL for the same actual URL.
So with that in mind, would it make sense to make username or email ID as a required field?
No,
it doesn't.
it's not compulsory, because it should not be compulsory because let's say we may, so again, it depends. We can make it compulsory, but we may not want to because it can give a bad user experience. Let's say if I want to create a shortened URL, I'll go to a link and I'll just type my actual URL. I'll click on generate short URL. I'll get the short URL. Okay, that's a two-step process. Now, if I want ask user to log in, so user will log in with their Gmail account. Then they'll give the permission. Then they will go to they'll put the actual URL. They will fill their. We can fill the username automatically. That's not a problem. And then then they'll click on generate button. That will be a 5-step process. So compared to 2-step process, 5-step process takes a time, and we may end up losing lots of users just because we are asking them to enter their personal details, or there can be privacy issues, or like if they don't want to share their private data with us, then we may we may lose lots of users. So it's mostly like a product call, but yes, definitely you can ask the interviewer this question in middle, while discussing whether we should support this use case or not. So again,
Yeah.
it depends on the interviewer, right? And it depends on the kind of system you want to design.
Yeah, the reason why I asked was, the idea behind generating different short URLs for different people, right? So based on what? So because the user might just give the actual URL. So how are we gonna generate different URLs every time? I mean, even the algorithm, right? It has to take some inputs
That
and
I
think.
will discuss with you right now. I mean, I'll discuss with you going forward that. So there is actually a standard, there is standard uh, algorithm to generate it, and that's how everywhere it is used. If you really want to go and read it in detail, then that is MD5 and SHA 128. I forgot the exact MD5 I have used once. I haven't used SHA 128, or what is the name? I forgot the name, exact name, but I can share that name with you guys later on. And then you can generate, you need to add some random salt in it, and you need to actually encode it with base 64 or base 32 byte, and then pick like first 6 digit of it, and then add a random salt, so that even if you have got the same hash values, you with the random salt you'll be able to generate 2 different keys for that, basically 2 different hash out of those hash values. So I'll discuss that as well. Like just bear with me for like next 5 minutes, and then we'll come on to that. Okay.
Sure, not a problem.
Okay. Any confusion so far? Okay. So let's, we should have some error codes as well here. We should not give the message like 404 not found if the URL is not present, or if we can't create the URL or your system is down. It should pass some actual meaningful error codes. So there can, so if your request fails because of some reason, or if the pick URL is already present, if this shortened URL is already present in your system, then you can return the same. So you may want to return the different URL altogether, or you may want to return the error code here in this case, because it depends. Again, it's a product call, but yeah, I mean, depending on the use case, you may want to give the error code. So there can be multiple error codes, like or error messages, I'll say. So you should always have a proper error codes and messages for your system. And definitely it will give it will give you an edge if you'll mention this in interview over the other candidates, because like most of the people will may come up with this solution, but the things which we have discussed right now, like error codes or username or permissions or privacy issues, this if you will mention in the interview, then definitely you will get edge compared to other students or other candidates. Okay. So yeah, there can be multiple error codes, like timeout. You can have a separate error code for timeout, separate message for timeouts. You can have separate message for this pick URL thing, or you can just return some random URL if that is not available for the user. Okay, let's go to the second one, which is like redirect URL. So this looks very like pretty straightforward to me. So what will be your request? What will be your response? So request will be your just short URL, and your response should be actual URL as well as short URL. This is again optional. You may not want to return it, but it's good to actually return the short URL along with the response, so that if, let's say, tomorrow you want to test something on your client or some other service, then you always have this option to pass the short URL along with your actual URL, so that you can easily map it. Or you can, if you may want to keep it in your basically your cache as well. So while reading, if you want to actually write it in your cache, you should have this short URL and actual URL in your response. Correct. Now, delete URL should be pretty much straightforward. What should be your I'm not writing it down because I mean it's an option in our case, but you need to pass your short URL. You need to log in with your system. Basically, pass your username and email address, and that should not be just passing username and email address. You should be able to log in first. So that check you'll have to have on your client side, right? Because I can pass the email address of some other person as well. So again, that can be a privacy issue. So you should ask person to log in and then only accept the email address which is entered in that field. But the client should take care of that, all those things, because those checks can't be on your service or server side. Correct. Yeah. To the solution for your question, what will be the algorithm to actually generate the this tiny URL? So so this is not a major reason, because this is already discovered and you can't come up with this algorithm within like days or within the interview itself. It takes days for the people to actually come up with this algorithm. So even if you don't know it, you can tell the interviewer that I'll come up with some. So in such question, the interviewer doesn't look for the exact algorithm you want to come up with, but you should be, because it's quite possible that I don't know what is MD5 or what is SHA 256, and I won't be able to come up at the time itself, because it took days or months or years for the people to come up with such algorithms. So I mean, interviewer doesn't actually expect from you to actually come up with the right algorithm at the place. But yes, like something like UUID is heard by everyone. So you can say that I'll generate a UUID. You will take some 64 bytes of that UUID, the basically your USB or MSB, and then generate a base 64 encoding generated URL for the user. So that is one of the solution. But again, there can be many more solutions. I'll tell you the URL, the algorithm which is usually used to generate this particular tiny URL. So basically what do we do is we have MD5 and SHA 256, which gives you a hash, basically a unique hash for the URL of the URL. And this unique hash will be always same for one of the URL. And then what do we do is that we actually encode. So now if so we got like some hash of in bits. Let's say we got some 128 bits or 256 bits. Then we create an encoding out of this, and the encoding can be 64 byte base encoding. What is 64 base encoding? So you can have the numbers from 0 to 9, comma, small a to small z, comma, capital A to capital Z. So this makes what? 26, 26, and 10. Plus you can have commas, sorry, not commas. Mostly you prefer hyphens and dots. Oh, sorry. You can have base 32 encoding as well. and you can have base 62 encoding as well. So base 62 will be pretty much same. It will have 0 to 9, A to Z, A to Z. And then you can have base 32 as well. Sorry. Base 32 as well, in which only 32 characters are considered, 32 different kinds of characters like 0 to 9. Okay, 1 to 9 is considered. I forgot the exact pattern used in this. You can actually create your own base as well. So 1 to 9 is used, then capital A to capital Z minus of, like I is not used here, O is not used here. So 26 plus 10 is 36. So there are O comma 0 is not used here, O is not used here. And I guess there is one more. I forgot what exactly that alphabet is. So there is one more alphabet which is not used usual from A to Z, and I forgot what that is. But yeah, this is base 32 encoding. So once you encode it with base 32, it will give you a number. Now, to answer the question that if two people have the same URL, then so everything will remain same till here. So what you do is you generate a random number with the help of UUID again. So you can have some random sort here. We call it as random sort, which will be again a random number, okay, which will add to this particular URL and then generate a hash out of it. Generate a random number of, let's say, some 5 digits or 6 digits, and then you will add this to your current, basically your this number which is generated from here, and then you'll create a hash out of it and finally store it somewhere. So basically your hashed URL looks like something. Looks base 64 of MD5 original URL. Now it's quite possible that you may not want to generate so base 64 encoding will give on 128 will give you approximately 26, as far as I remember, 26 character. There is a standard algorithm for it. You can go and read on the internet, but no one will ask you that in the interview for sure. And you may want to take only the first 6 letters, but once you slice down, there can be many more, URLs which can be found out of this. So you need to add some random sort in it. It's like a random number. And the probability of getting the same URL is very less. So anyways, your database will be able to handle that call because it will have uniqueness on your hash URL. So this will be my unique for each of the requests. Correct. And what else? Am I missing anything here? Yeah, the algorithm which actually I mentioned by myself, which like you can't think of that. You want to come up with some algorithm quickly in the interview, then you can say that I'll generate a UUID for a particular URL. For a URL, I'll generate a UUID, and then that UUID, I'll take the 64 bits, basically 8 bytes of MSB or USB or USB. You can take any of the 8 bytes. So this will give you a 8-byte number, and then on 8 byte you can do a base 64 encoding or base 32 encoding, which will generate a number for you. You can actually slice it down to the first 6 and then add the random sort. Yeah. So you can come up with multiple algorithms. Actually, no one expects you to come up with the right algorithm in the interview. And it's okay, as long as you are keeping this, you are maintaining this uniqueness, it should be fine. And UUIDs, as far as I know, like all, as far as, most of you have used this, most of you might have used this UUID in your system somewhere, sometime, right? So you know that this ensures a uniqueness across systems. So it's good to have UUID. you can use this and tell the interviewer that you can use UUID to generate the unique hash key. Any confusion so far? Then we'll jump onto the DB design because we are short on time. I want to keep extra 10 minutes for the questions as well. So if you have any question here, then feel free to ask. Anyone? Yep. Okay, no questions. Okay. So we are done with the algorithm part. Now we want to store this data somewhere in our DB. Okay. So what should your table look like? So let's discuss out that as well. So there are few observations we have made so far. We have to store billions of objects. 50 billion per year, per month we were generating, per year we were generating some 30 billion URLs, right? Where is that assumption? This is the hit redirectional. Yeah, 30 billion writes. So basically 30, so our system should be able to. So initially we don't want 30 billion because we know that's our estimation for next 5 years. So we can start with, okay, I'll talk about the scaling later. Let's note down the few main points we have observed. So billions of objects we need to store in our DB. That is one thing. Second thing is that each of the object is fairly small. It's like 500 bytes, which is not even like 1 TB. Oh, sorry, what 1 KB, less than 1 KB, we can say. 1 KB is equal to 1024 bytes. And it's a read heavy system. As I mentioned, it's not a write heavy because 30 billion into 100 will be our read in next 5 years. That is what is our estimation. And then there is no relationship between the two different rows. The rows are not related to each other. Those are the independent rows, and we don't need to care about the, like, we just need to read one row at a time to return the response for a particular query. Not related. And cool. Now we want to create the tables. So can anyone tell me what all tables we'll need here? Yeah, I'm waiting for your responses. Okay. So one we'll need is URL table. In which what we'll store is hash key. Correct. Then we'll have actual URL, shorter URL, expiry time, and user info. Can anyone tell me what will be the primary key of this table? Let's say user ID here. And this will be my primary key because this is the only thing which will be generated uniquely for each of the actual URL, correct? And you can have short URL as your primary key as well, but you may want to delete some values, and as you're generating a hash key for each of your actual URL, I think it's better to keep hash key as your primary key. Because let's say for the two actual URL, if you have the same hash key generated, then you can just simply avoid it. And then we can have a user table in which you can have user ID, which will be my primary key here. Some other infos like name and email and some other tokens which are passed as a privacy tokens, I can say. You may not need this field, but it's good to keep it. And this will be the foreign key of this table. So there is a, so for a user, and this can be, yeah. Any confusion so far? Any questions so far? And this is like an optional field. So if it is not filled, then it's fine. We should not mention it as foreign key because this is an optional field. It's better not to keep it as foreign key. But you know that always a user ID will be ready. So you can always perform a join easily if it is filled. Yeah. Any confusion or questions so far? So our DB looks good, right? Now the major problem is that we know that our system is read heavy, and we have to handle the traffic. And you can't store everything in one database because you need to do some scaling at some point of time. You may not get a DB of like size 30 DB at the 15 DB at the first place. Plus, it doesn't make sense to buy a have a database of 15 DB because your traffic, that is the estimation for next 5 years. Initially, you can start with some smaller DBs as well. So what you can do is you need to store this data. So initially you can start, so there should be some partitioning algorithm. It should be able to partition your data in a correct way. There should be some clustering. There should be some, you need to create a replication of that data. So there should be some replicated machines for each of the data we are doing it. And then you should have some, multiple servers, data servers to handle all the load. So let's try to write that down as well. Yeah, no confusion till here, right? Feel free to ask if you have any confusion. This will be my user table, I can say. So you can start with a machine, as I mentioned. A machine and scale as traffic increases. Or you should have the right strategies to actually able to scale your system as the traffic increases. So this is the most important point because you are starting with a machine and then you want to add more machines as the traffic increases. Correct. So mostly there are like two different, partitioning we follow. So one is your range-based partitioning. So in range-based partitioning, what happens is that once, let's say I start with a single machine, okay? So let's say I have some 50, 100 values in this machine. I'm assuming like it will be much more than 100, but I'm assuming. So let's say some entries start with A, B, C, A, B, D, then D, A, C, D, E, B, and then you have actual URL. This will be your shortened URL, you can say, or hash key, and E, F, G. Okay. Now what happens is that now you know that there is a lot of load in this machine. So what I can do is later on, I'll split this machine into two parts based on the starting point. So all the I need to migrate, I just need to migrate the data here. So this will become A, B, C, because I know there are so many requests coming with starting with A. So actual URL basically, I'm doing it on, so let's assume this is my actual URL. So I know that it is because of, it's coming with, there is a lot of load because of A. So I split it A in a separate machine and then kept all these values in a separate machine. Now, later on, let's say I know that again, A, there are so many values coming for A. So let's say again, A, D, E, A, B, Q. Now I need to again split this machine. This is working good for me. So I'll say I'll do on the basis of first and the last character, first and the last character. And I know A2, AB2, AA2, AQ I'll keep in the first machine and later we'll keep it in the separate machine. Or let's say M and AN. Okay. So this ABC, ABD will come here, ADC will come here, and APQ will go here. And whenever you get a request, you can easily handle, because you know, like the database, the entry in this database is from this to this hash. The entry in this database is from this to this. The entry in here, this should not be actually ordered, sorry. Yeah, so you can easily go and check it here. Correct. Any confusion so far? Any questions? But see, the problem with this is that if this goes down, if this machine goes down, or if you want to, you need to always keep a backup for all these machines, right? And it can lead to an unbalanced load as well. So let's say now the requests are coming only on with starting with A. So the load will again come to this particular machine because it's a read. So here it's a write. So this we are writing on the basis. These are all. So this is for the write thing, right? When we are creating the database based on the write strategy, that any write with ABC will be happening in this machine, with AP after AP it will be happening in this machine. But now let's say there are so many reads coming and all those reads are for ABC only. So this machine will become read heavy and all the requests are coming for A only, let's say. So these machines will become read heavy and there will be a lot of load on these machines, correct? So this doesn't scale. So you can say that this doesn't scale very, very good. So there is another partitioning algorithm, which is hash-based partitioning. I'll discuss this hash-based partitioning in detail in other class as well, but just to give, okay, just try to understand this. If you have any question in the range-based partitioning, then please ask question. Let me small it down. Yeah, then I'll talk about I'll give like a 30 seconds for you to quickly go through it. Yeah. Okay, if that is clear, then I'll go to hash-based partitioning. So what does that mean is, now, because I can see the problem was this, that all the queries with A was coming here. So you've seen, right, we have created a hash value or a short URL for this. What I can do is on that hash URL, I know like I have 20 machines right now. So, so what I'll do is for the 20 machines, I'll do %20. I'll create for that hash value, I'll do a hash value. I'll do a % of the number of machines I have currently in my system. Correct? So this will give me some value, and based on that value, so let's say I have 20 machines. So if my hash value is, let's say this value was some 200, I have 10 machines, so this will give me 0. correct? Now my hash value is 205. This will give me 5. So I have numbered my machine from 1, 2, 3, 4, 5 up to 20. Now I know that I need to put this value into my 0th machine. Always. I need to put this value into my 5th machine. And I know 5th machine. And I know that the number of machines are constant right now. So the values will be here and here. If it's, when it's a read, when I'll do hash value percent number of machines, it will be the same value. The problem with this approach is that the number of, if you want to increase the number of machines, then you need to rearrange all this data again because your number of machines are changed and the hash value percent number of machine will change because for each of the value, because you want to have the write and the read in the same particular machine, correct? So that will be a problem. So for that, we have a concept of consistent hashing. That's altogether a new topic, but yeah, I'll discuss this as well in some other class. You can easily solve it with the help of consistent hashing. But the load part now became, the load will be equalized on all these machines because we are calculating this on the basis of hash value and not with on the basis of your starting shortened URL. Correct. So I'll discuss consistent hashing in some other class. So this is the, like, these are the major things you need to keep in mind while designing your system. And yeah, one more thing here. So we know that here the write should be done in a single transaction. So it's better to use a MySQL database and SQL DB here because it should be a part of one single transaction. So it's better to use SQL here. Now coming on to the load balancer. So what is the use case of load balancer? So let's say there are hundreds of requests are coming onto your system. Now you want to distribute the load evenly between each of your services. So you put the load balancer. Load balancer actually keeps listening to each of the services and each of these machines, and if they are not down, and what is the number of what is the load on each of the machine. So load balancer always try to balance the load between all your machines, so that it doesn't become one of the machine doesn't get overloaded and goes down. So that is the main use case of load balancer. So we're putting one load balancer here, we are putting one load balancer here. Because we can have replications of this data as well, right? That I'll discuss is the part of consistent hashing, that how can you actually maintain the replications as well. So let's say if you are in your current system, okay, if let's say this machine goes down, what happens to all those values which I have stored so far? It will be very difficult. I mean, I won't be able to retrieve the data. The data is lost with me, and that will give a very bad user experience. So we have something called replications and clustering and partitioning that I'll discuss in more detail with consistent hashing. Okay. Yeah, time for the questions. So guys have like 10 minutes. If you have any questions, you can feel free to ask, or we'll wrap it up. And I want to hear the feedback from you guys as well. Like, was it helpful? I know, like, you might not have consumed everything out of this lecture, but even if you have done like 70%, and if you revise it again, I think you'll be at 90%, which is good enough for any interview. Yeah. And always there is like a lot of online data available. With this data, yeah, at least you have a good understanding of shortening URL. You can go and understand more in details if you want by yourself. Like if you want to read MD5 algorithm, you can go and read. But I never done that because I know it's usually not used and not asked in any of the interviews as well. And I mean, you'll use maybe once in your lifetime or never. I haven't used it yet, so it doesn't matter. I've done some kind of shortening, but I haven't used the MD5. But my system was not that. I mean, I designed it for a very other use case. So here the use case was totally different, which we are discussing about. Yeah. Any section you want me to zoom in, then just let me know. Yeah. Any other questions or confusion? Any suggestions which I can put in the next class, which will help you to understand more a better way. Yeah, feel free to speak up.
Yeah, I have one suggestion. If you can take up that topic, actually.
Which topic?
Right now, like load balancer you are talking about. So, is there any open source or anything there where we can test our? If we are writing something, we can test.
Actually, you can write your own load balancer. So, so there are two things, right? So there are actually hardware available in the market, which like most of the big companies buy to actually balance their load. So the way it does is that it will. I can actually take that topic sometime in the next class, like how load balancer works exactly, how it listens to the what are the heartbeats in load balancer, how does it communicate with each of the machine, uh, how does it know like I have to shift my load to some other machine, this is getting more load heavy. I can definitely discuss that out in some other class, maybe next class or next to next class, depend on the topics we are discussing. But yeah, I can take that up, definitely. It's very helpful to know the details of the load balancer. And I'm not sure if there is any load balancer code available online. Actually, we can check. So you can create your own load balancer as well. Yeah, so there is this load balancer algorithm. Udacity course is there. You know, there is round robin, weighted robin. I don't know. I've heard of this and this. I haven't heard of any other one. These are the multiple algorithms. Yeah, actually, you can read it. So yeah, this is what is I'm talking about: active transactions, active heartbeats. So there are so many algorithms. It depends on your use case again, what do you want to use it, what do you want to use, but more or less the underlying concept remains same, that you want to balance the load equally as equally as possible amongst your servers. Yeah. So yeah, I mean these are the two very famous ones, and these are the only ones which I've read. I can discuss one of those in one of the classes. It should not take more than like 20 minutes. I won't go into the deep details because you can easily get it anywhere, and like people don't prefer to have their own load balancers and write their own algorithm. It's better to actually buy. I mean, people prefer to buy load balancers for their companies because those are. Okay. What is this one? Proxy is open source Apache one. Is that a load balancer you're talking about, Nagappan? Nagappan? I don't know. I haven't heard of this because in Google, like they have their own load balancer, so we don't even care about it. I mean, we don't need to because that is all abstracted out from the developers. So, yeah.
Hello.
Yeah, tell me.
Yeah, I think HA proxy is a load balancer they generally use in the distributed environment, right? It's an Apache product.
Oh, okay. Okay. Actually, I'm not aware. Maybe go and search online. You can share it with other people. It's already on the chat. Heproxy is an open source Apache load balancer. And you can read the details. You'll easily get these details if it's an open source on Google. You can always read about it if you want in details. But yeah, I mean, I'll be happy to discuss the underlying concept of it. I'll take it quickly. I won't spend a lot of time on it, but yes, I'll take it on something. Yeah. Any other suggestions or questions you have for this? Was this lecture helpful for you guys or not? I'm not sure if you are aware of all these things before, and anything new you have learned from this, anything which we missed in this class?
Yeah, the class was useful. We got to know a few of the things. So this long URL conversion can be used for a deep link URL also.
Sorry, I didn't get you. Which one you're talking about?
Yeah, we were saying we are going to convert the long URL into a short URL, right? So in the long URL, sometimes the URL will be a deep link URL. After the URL, there will be a hash and then the um, some name which is referred within the part of the page, right? So
Okay.
that kind of deep link URLs also.
Yeah, you can definitely use it as a part of deep link URL. So that's what I do. So, I mean, it's good to have. It's okay if you don't have that, but it's good to have that as well, because you know what happens is that if it makes it. I mean, if that's a readable URL and if you user want to go and read, then only they can go and read. So there is no harm, right? So we are just giving a system. Anyone can put any kind of URL and then yeah. So you can definitely generate a deep URLs as well for. I mean, this system doesn't actually care about that at all. So there is that's not a blocker for you to actually generate a short URL for a deep URL.
Okay.
Any other question?
Apart from that, suppose certain URLs will be a protected URLs, right? Like after authentication only we get into few of the things. So those kind of URLs, if they try to create a short URL, even though the short URL is got created, when they try to hit the short URL, it will go to the again a login page, right? It won't go to the actual
No, no, no,
resource.
no, no, no. So for the redirection, we are not checking any authentication or authorization. We are checking the authenticity only when we want to delete the URL. So redirection should not be a problem. So redirectional facility should be provided for each and every user. When a user want to delete a URL, then they should have the authentic permissions to actually delete the URL. So that should not be an issue. So redirection doesn't restrict anyone from having any kind of authentic auths thing. Yes, if you want to have some kinds of auths, it depends on a particular use case, then you will have to have some kind of permissioning thing in your system. And like you can have another column which says like only to these people the permission is there. And then you can have another, another support for your, you can have another API in which for the particular URL, you should be able to add more people should be able to add more people to access that URL. So you can have some other URL called other API called add accessibility or add user to user accessibility, or you can have some kind of good name for that particular API, which will just add the particular user and give the permission to that particular user for accessing that URL. That can be managed on your server side. That should not be a big problem.
Okay.
Got it? Or I mean, that's what you are asking for, right?
But it's something like this, like for example, I have a photo uploaded into some my Google app, and that URL is there. Okay, so by logging in, only I can access that photo. Okay, so but therefore now I give the photo URL and convert it into a tiny URL, and
Correct.
I try in some other system, okay, which where I didn't log in as a Google user. That time if I try this tiny URL, it will go to the actual URL. So that time it will the Google server might redirect to me a login page, right?
So sorry, Google server will
Will
redirect.
yeah, actually the short URL will point to the photo URL. So
Correct.
when the photo URL tries to hit the Google server, I will not be an authenticated user because in that system I didn't log in.
Yes. So it depends, right? I mean, but this system doesn't restrict you. That's the Google side servers or the Google APIs which are restricting you. That we can't anyways handle on our side. So if Google is giving that permission, right, to access. So actually Google should give the so see, you were able to convert the short URL into long URL from our system. Now Google is not authenticating you as a right user to actually access the long URL. So that is something which has to be changed on the Google side, not in our design, right? Because the aim of our design was to just give a long URL for the short URL. That's it. Correct. So
Yeah.
redirectional performance.
Yeah, correct.
We are not stopping the user to redirect to the longer URL. The Google servers are stopping the user to actually get the photo out of that long URL. You getting my point?
Yeah, got it. So in this case, I'm not sure. It might be a crazy thinking also. When I take the URL, I can take the token also, some OAuth
No,
token or
you should not, because see, you should not. Why? Because why Google will actually share their data tokens with the other systems. I will not. I will not do that in my lifetime ever. I don't want to actually share my data tokens of the user with you with some other system. I should not do that at all. If I want to authenticate user, then I should do it in my system, right? I should have some kind of URL. I mean, see, this system is you just used to convert a short URL into long URL. Why should I give my users details to that system at all? I should not do that, right? You getting my point?
yeah, got it.
If I want to authenticate the user, then I should do it on my servers, my system, right? I should not share that details with any other systems. Correct? You getting my point?
Yeah, got it.
Yeah. Yes. Cool. Any other question? Okay, guys. If you don't have any question, then yes, thanks for joining. I'll ask Aditya to actually share these this document, not the document. Basically, you'll have the video, so you can always go through it. I don't know if it is possible to share this document or not. I'll just check with people here. If it is possible, then they'll share it with you guys. Okay. Cool. Thanks for joining. There is some message. Cool. Thank you. Bye.
Yeah, thank you.